So, hello everyone, and welcome to the first episode of the podcast Tech Upgrade series. This is a series of podcasts where we will analyze what is the Tech Upgrade project, a project funded by the European Commission under Horizon Europe program. And also, we will gain some insights from the actors, the main actors of the project. Before we begin, please make sure that you follow our social media pages on LinkedIn, Instagram, and X, X Twitter, and also that you are subscribed in our Spotify and YouTube channels. All the relevant links, you will find them below in the description of the episode. Today, we had the pleasure to have with us the coordinator of the project, Dr. Ahmad Arabkoohsar, uh, who will tell us everything about the project, and he will give us a general overview of what is Tech Upgrade, what we are doing in this project, and how it evolves. So, Professor Ahmad, thank you very much for being with us. Can you please introduce a little bit yourself? What is your job in DTU and Tech Upgrade, and also to give us a little bit of an overview about the project?
Yes, of course. Thank you very much, Alexandros. It's a pleasure to be here talking to you. Yes, my name is Ahmad Arabkoohsar. I'm a professor at Technical University of Denmark, and I lead the research group Smart Thermal Energy Systems, which is the house for some, if we don't say several, EU projects and also Danish national projects, mainly working around sustainability and thermal energy systems.
Okay, and what is Tech Upgrade?
Good question. A Tech Upgrade is actually a technology-driven project where we have teamed up with several EU leaders of academia and also leading sustainability companies around Europe to develop a technology that could help us recover waste heat of industries and upgrade them for the processes in a sustainable manner. So we are actually trying to decarbonize, at least contribute to the decarbonization of industrial system in Europe.
Okay, and why is this important?
Well, it's very important because first of all, we are dealing with these climate change phenomenon, which is actually a big dilemma these days for us, for the world. So we have to control CO2 emission. We have to mitigate it, actually minimize the CO2 emissions. And one of the biggest sources of CO2 emission is industry. And if you look at the industry from different perspective, process heat is the major contributor to the emissions. And so we have to find a way of supplying heat to the processes in industry in a sustainable manner. If we can do that, then we are controlling, minimizing emission across the industry in the world. Okay, of course we are talking about Europe when we are talking, because this project is funded by the European Commission, but of course we are targeting the entire world's energy market. So that's the aim, minimizing emissions across industries.
Okay, and why is this difficult? I mean, why anyone else did it already, and why the European Commission funded Tech Upgrade? What is the important thing that they spot on this project?
Well, the thing is that technology developments have been always in the same direction as the needs of the people, right? So far, probably in the former decades, at least to the last few decades, sustainability and global climate change has not been a big issue. So technologies that could supply sustainable heat have not been of like much of interest. Maybe there has been, and there has not been enough effort to develop technologies for this purpose. So that has been, of course, a kind of technological gap so far. Then all of a sudden, EU policymakers, decision makers understood that, okay, we should do something about that, right? So they have been thinking of what are the sources of emissions, where are the gaps, where, especially technological gaps, and then these should be addressed. One of them has been this, and it is very difficult to address because of these significant technological gap. For example, if you look at first of all, I should tell you that there are different pillars of research and developments that are needed for addressing this sustainability challenge in industry, like digitalization, like electrification, or like waste heat recovery, one of them. So different pillars. And for any of these pillars, we need to see how we can do it and what are the gaps. So how we can just fill the gaps in between. For industrial waste heat, for example, we just mention high temperature heat pumps as a competitor technology, which is very much of interest, of course, and also is at the same time, with one technology, you are addressing different pillars like electrification, heat recovery, heat upgrading, different ones, right? With one technology, but that's difficult because you don't have a technology that could do. Heat pump technology that could do heating for you at high temperatures. Today, let's say 160, 150 is the state of practice, and 180 has been a state of the art where our R&D projects are demonstrating. Maybe some people are also talking about 200, but in reality, there have been some successes, some like kind of failed projects around that. But you see, that's very difficult to go higher than some certain levels with high temperature heat pumps. Then, of course, cost is a big matter here. You can develop some technologies, but those are very expensive. Solar heating is like a kind of key technology. Of course, it's very much sustainable, but it's very expensive, especially when the temperature goes higher than a certain threshold. Again, it becomes very expensive. So, yeah, of course, technological gap, cost, different things make this very difficult.
Okay, and let's jump into the project. Can you please describe us in very simple terms uh, how is this configuration of that Tech Upgrade wants to achieve? How it looks like? What is it?
Technologically, you mean?
Yeah.
Well, yes, of course. Tech Upgrade is very innovative. It's around thermochemical principles, and thermochemical itself is kind of a young, if I want to be kind with it, I can say it's a young kind of knowledge or field of science. Of course, it has been there for many decades, but not that much of progress because of different things. So Tech Upgrade is coming and taking advantage of those principles that have been there. I'm trying to talk in simple language, right? So to actually use this waste heat of industry to act as a kind of actuator of a process that we call it endothermic. If you just actuate, imagine that you have two elements that are peacefully living with each other jointly, right? In as a single element A, element B, just merging with each other, living in equilibrium as element C, right? So if you want to decompose this, you need some forces. For example, if I want to decompose my hands from each other, I need force of my hand, right? Or my body to just decompose these. But for Tech Upgrade or thermochemical process, you don't need that kind of force. That force is indeed heat. So you give the heat, and these two elements separate from each other. And by nature, and based on those thermochemical processes, if we let these two A and B elements to come into each other again in like a kind of, we call it equilibrium condition, which means at desired temperature and pressure, then these start merging with each other, forming joint element C. And again, this process releases the same amount of heat as used to decompose these. So imagine how this could be helpful. You can use the waste heat of industry to just decompose element A and B, right? What is element A and B in TechUPGRADE? Element A is salt, element B is water vapor. These jointly is called salt hydrate. So you just use the waste heat of industry to decompose salt hydrate, make it a kind of dehydrated salt, let's say salt, and water vapor. And if we let them just merge again with each other, they just make a chemical reaction and just release the same amount of heat. But it's the same temperature because it's the same equilibrium condition. What we do in TechUPGRADE, we just manipulate the reverse reaction when these are going to merge with each other. We just manipulate this. Mainly, it's playing with the pressure of the reaction, and we boost up the pressure of the reaction. And in this case, the process releases more heat. However, of course, this time you cannot release the same amount of heat as that used to decompose these, because for making the system to come to the new equilibrium condition, you need some extra heat from somewhere else within the process, and you just release less heat than what you used. However, it is still of much benefit because you get the heat at higher temperature, which could be used for process heating. So you have some low temperature heat that is very valuable, but you don't have an immediate heat, in immediate use for it, an immediate application for that because it's low temperature heat. You use it with this technology, upgrade it for higher temperatures, but lower amount, that's fine, but higher temperature that the process can use it. Very much sustainable, pure sustainability you can see here, and also pure innovation, isn't it?
Yeah, I can see the innovation, and what I am thinking is how you got into this idea. Is it something, I mean, out of the box, innovative, or is there, some research behind it that based this argument, this idea?
Yes, yes, of course. First of all, we should know that TechUPGRADE is a TRL5 project, Research and Innovation Action, right? So this means that the concept and whatever that you want to develop, like kind of, we have TechUPGRADE in different levels of innovation. A material level, which is micro level, like kind of component level, which is also called meso level. And then we have it in system level, sometimes called macro level. In any of these, we have innovations, but we cannot start from scratch. It should have been developed, proposed before to some extent, and then we just promote that innovation. We have this kind of innovation and promotion of technology readiness level in all these levels, from materials that our colleagues and partners at TU Vienna are working on it in like kind of material component level, different partners, and system level that is mainly DTU and DLR are responsible for that. So this has been there, but in different ways. And also proof of concept level, people have tried this. For example, is this upgrading concept working quite well and cyclable? Let's try. And DLR has established a 1 kilowatt reactor for that and has tested there. So it has been very promising. So why not upscaling that? But there has been many challenges that are actually identified previously, or when we have been developing this concept as a proposal, and then we are addressing these challenges and gaps within TechUPGRADE.
Okay. And I see the benefit for the industry.
Yeah.
And you will explain us what are the benefits of the industry. But the greater impact for the European societies, which is the the let's say the cornerstone of what we do in European projects. What is the benefit of the European societies? First, explain, please, the benefits for the industry, and then we come to the greater impact about the
Yeah.
European societies.
Yes, for industry, of course, the first impact is sustainability. We want to get rid of CO2 emissions within the processes and also making the processes more cost effective. Imagine that you have much heat. I don't have in mind the exact number, but hundreds of terawatt hours per year of waste heat at different temperature levels, and you don't do anything with it. That's all it is, money, but I would call it flying money, right? It is, I mean, it is energy, but it is kind of flying money, right? It's just going out of the window. We are just harvesting those wasting resources and returning them back to the processes, and that's saving a lot of money and energy, and of course also sustainability thing, because we are reducing the emission of the processes. So both money, economy, and also sustainability are the benefits that the industry is getting from that. And if you want to talk about that in a broader perspective, we are talking about the EU Commission. EU needs to be pioneer of technologies compared to the US, as and also today China. So we need innovations. We want to remain as technology drivers, innovation drivers in different things. In some aspects, we are losing the competition, of course, no doubt. But in some others, we have been the pioneers. We want to keep the competencies and even boost ourselves. So being the technology driver for some game-changing technologies like this is a key here. And also, if you look at the EU Commission, the borders, I mean, people would benefit from this. Better economy of life, because when industry is working more cost effective, material costs would come lower, and actually then you have better living environment in terms of pollution, health of people, a lot of different types of benefits like this for the society. So this is, I would say, a broader perspective of benefits for the EU.
So there is this sequence that if we do the industry more cost effective, this will reach also to the average European, because we will get also more cost effective products or services. Or is this the kind of sequence that you talk about?
Absolutely, yes. And thank you for rephrasing this in a nice way, more understandable. Yeah, absolutely, yes. It will come. There is no way that we think, okay, industry is benefiting, going for more cost-effective processes, making food products cheaper, making a car, everything that you have in your daily life at much cheaper, at much lower cost, and then it doesn't come to the life of regular people. Of course, it would come. So that's also a broader benefit.
Okay. I know that Tech Upgrade project has 14 partners from different European countries. How you manage that as coordinator? I
Oh,
know it is hard, but
yeah, it is. Uh, yeah, I can say first of all, it's a blessing that we have these partners. All of them, I can say that are professionals. Uh, they have been part of different projects. Maybe not all of them part of EU projects, but they have at least had national projects of big scales. And they know how this works. This makes life much easier for me when I try to make coordination. And when the consortium is that big, the tasks are also big, and then the headache is also big. But these people, when you are definitely there are dilemmas, there are challenges when you just reach to those points. Risk management, project management, relation management mean a lot. And here, talking to these people, risk management and relation management is really easy. You have seen such cases as a partner in this consortium, and you see that this is really efficient. Fortunately, in this project, I'm really glad that these people are really easy to work. That's the key, being easy to work with.
yeah, they're really
Yeah.
easygoing people. Yeah, I can tell.
Yeah.
Okay, we are now in the third year, if I'm not mistaken, of Tech Upgrade project. Which are the key milestones that we achieved so far?
Well, the thing is that so far, I can tell you that we have been mainly in the desktop uh, work stage. doing a lot of simulations, even for the type of works that needed more kind of hands-on work and development. Still, we need some desktop work to first try our models, our ideas in computer and computational models and simulations to see if they really work, and if thermodynamic and physical principles really support our ideas and innovations. If these are positive, then we go to the hands-on part. And this has actually, I can say, come to a very good conclusion now. Then the pragmatic part of the project starts, which is of course of more challenges, because this is more chaotic than working with computer. And of course, because we are very lucky to have, I really think it is fair to say we are really lucky to have DLR as part of this consortium, especially Dr. Mark Linder, whose experience in working with these types of systems, thermochemical systems, at like kind of system level tested within lab, out of the lab, that's a big help. And you see that the negotiations and arguments that we have started for the demonstrators are now progressing quite well. It is a very critical time of the project now, because we are starting the procurement for the demonstrators. We have two demonstration sites, one at DLR, it's 5 kilowatt hour, 5 kilowatt capacity, and one in Sweden, which is supposed to be solar assisted or possibly solar driven pure. Then that means a lot of technological innovations, and also complex procedures of testing and establishing before testing, of course. Things have started, and the next step is to make sure that the setups are established very well at high level of accuracy and precision, and we are working on it quite hard. I believe in 6 months or such we can start testing.
Okay, and you said Germany and Sweden.
Yes.
What do we expect to find there? Taking into account that we, as you said, we are a maximum TRL5 project, what do we expect to gain from these demonstrators?
Yeah. These are two different types of systems that we will develop and test there. Apart from the fact that the test setup in Sweden will be solar assisted, which means we, for the cases that we might have waste heat or we might not have, still solar is a part of the game. If there is no waste heat, there might be some electricity to heat conversion as part of the game, and then still solar also the remaining part of the game, but also it might be pure solar. That's one difference, big difference. But we have more differences here, even more fundamental. The one that at DLR to be tested is actually a kind of continuous operating system with 2 reactors. But the one that we want to test in Sweden is actually a storage upgrading concept. So we want, because it is the nature of the work, when you have solar energy, you need to have storage. You cannot rely on continuous operation 24/7. So you need to have a storage capacity. And then in the meantime, we want to also have upgrading possibility, right? So the thing is that in Sweden, we will have one reactor working as hydration and also dehydration reactor. So that's the difference. When you have one reactor, you cannot do both hydration and dehydration, meaning heat recovery and upgrading at the same time. So you just do heat recovery, just give it the time to be completed, and then you just do the heat upgrading and supply to the processes. It's like kind of a storage concept.
Okay, so we are approaching to the end of our conversation, and if our listeners have to remember one key message from you about Tech Upgrade project, what is this message?
A good question. I would say how to team up in a very multidisciplinary manner to make game-changing innovations. TechUpGrade brings together specialists from very different worlds: mechanical engineering, or if I want to just be broader in classification, engineering, mechanical, power, control, everything. Then from material scientists who are mainly fundamental researchers. See, mechanical engineering, especially in my field, which is thermal sciences, is very system level development. That's not really close to fundamental research, working with molecules of, materials and things. But we have brought in material scientists to fill that gap. And also, we have brought social scientists, we have brought in sustainability scientists, environmental sciences, and many, many different fields. And also from policies, from those who are really experts of business and market, to not only develop this technology in a kind of reliable way and, of course, promising way, but also be able to push it towards the market. If we develop a technology that cannot make an impact because it cannot compete with other technologies, or even if it is a golden technology, you don't have the skills and capacity to push it into the market among those many competitor technologies. So what's the point? Why are you doing that? So innovation and multidisciplinary research, I think these are the keys for TechUpGrade.
I would summarize it like the right teamwork makes the dream work, something like that.
Yeah, definitely.
Okay. Dr. Arabkoohsar, thank you so much for being here with us. It was a pleasure to talk with you, and thank you also to our listeners for being here with us and listen and watch also this podcast last vidcast. Please make sure that you are subscribed to our YouTube and Spotify channels because more episodes are to come, and also that you follow us in our social media in order not to lose any news. And see you soon.
Yes, thank you very much.